Hi students, this is AJ sir. Let's study 9th standard ICSE Math 7A and 7B. First, let's study the laws of indices, also called exponents or powers. The first law, when two numbers are multiplied and if the bases are same, then the powers are added. So a raised to 7 into a raised to 4 is a raised to 11. On the other hand, a raised to 3 into a raised to minus 6 is a, because the base is same, and 3 plus minus 6 is 3 minus 6, which is minus 3. By the way, this negative power can also be written like this: 1 upon a raised to 3. So when you want to convert a negative power into a positive power, just do the reciprocal. However, that doesn't mean that minus 7 cube will become 1 upon 7 cube. This negative sign is for the base, not for the exponent, so we can't change that by reciprocating. Next, we have the quotient law. So when you divide two numbers and the bases are same, that is a and a, they are the bases, then the powers 3 and 6 can be subtracted. So it will become 3 minus 6 minus 3. So again, this is nothing but 1 upon a raised to 3. Now, if there is a base, say a, power is minus 2, and the whole thing is raised to 5, we can simply multiply the powers. So this will become a raised to minus 10, which is the same as 1 upon a raised to 10. Next, what if two numbers are multiplied and then it is the whole power, whole raised to a number, like 2 into 3, the whole raised to 5. Then this power 5 is for 2 as well as for 3. So it's 2 raised to 5 into 3 raised to 5. This is true even for distribution. In division, the power goes to the numerator as well as denominator. Also, the nth root of a is the same as a raised to 1 upon n. So the cube root of a is a raised to 1 upon 3. Fourth root of a is a raised to 1 upon 4. Eighth root of a is a raised to 1 upon 8. Square root of a is a raised to 1 upon 2. So square root of 2 can also be written as 2 raised to half. Square root of 10 can also be written as 10 raised to half. Or cube root of 10 can also be written as 10 raised to 1 upon 3. Next, what if the power is a fraction? Well, the numerator of that fraction, which is in the power, will stay as it is, but the denominator will become a root, which is something like this. If you have a raised to 4 upon 5, that is the same as the fifth root of a raised to 4. Take this example, for example, 5 raised to 2 upon 3. That is same as 5 squared, the whole raised to 1 upon 3, because 2 into 1 upon 3 is after all 2 upon 3. Now 1 upon 3 is nothing but cube root, so I can write this as cube root of 5 squared, that is cube root of 25, which can't be solved further, of course, without using a calculator. Similarly, if I give you fifth root of 3 raised to 8, then this nth root will become the denominator here, so it will become 3 raised to 8 upon 5. The next rule states that if we have a power, then we can shift it to the denominator, but the sign will change. If it was positive power, it will become negative, and if it is a negative power, it will become positive. Next rule states that anything raised to 0 is equal to 1. If I have minus 1 the whole raised to 0, even that is equal to 1. Now note that whenever you have a negative number and the power is an even number, then the negative sign goes away, because this is minus 2 raised to 4, which is minus 2 into minus 2 into minus 2 into minus 2. 4 times negative sign has come, and in multiplication 4 times negative sign becomes positive. But if it's an odd number, then the final answer will remain negative. So this will be minus 32. 2 raised to 5 is 32. Final answer is minus 32. Now, if I write minus 2 raised to 4, the answer is minus 16. Here minus sign won't come, because won't go away. It will still be there because there is a bracket out here. If there is a bracket, then it means that the negative sign is also coming 4 times. So armed with these rules, let us start solving the sums. In question 1.2, we have to solve this using the laws of indices. So first of all, 5 raised to minus 4, I'll keep it as it is. 125 becomes 5 cube. And 25 becomes 5 squared. Now here, the cube 3 and 3 gets cut. So what is left is 5 raised to 5. And here 2 and 2 get cut. So what is left is 5 raised to minus 1. Now when the power is negative, let's make it positive by doing the reciprocal. So this becomes 1 upon 5 raised to 1. No need to write the 1. But whenever we divide with a fraction, we can multiply with its reciprocal. So again it becomes 5 raised to 1. Now here the sign of the power won't change, because here we are using the law of division and multiplication of fractions, not the law of indices. Now here we have multiplication and the bases are same, 5, 5 and 5. So the powers are minus 4, 5 and 1. So add them together. Minus 4 plus 5 plus 1 is 2, and the answer is 25. Now in question 1.5, this is the given expression. So first we will convert the big numbers into the smaller numbers using their factors. So here, interestingly, both of them are powers of 4. 2 upon 3 raised to 4 into, multiply this power. These are perfect squares, so 7 upon 3 squared divided by, these are perfect cubes, 7 upon 6 cube into 2 upon 3. Now 4 and 4 get cancelled. Then the squares get cancelled and the cubes get cancelled. So we are left with this expression. Now I see a negative power, so let's make it positive by taking the reciprocal of the base. And I see a division sign, so let's write multiplication with the reciprocal of this fraction. Now notice here the sign of the power did not change, because I did the reciprocal simply because of the rules of division and multiplication of fractions. Whereas here I use the rules of power, so I change the sign. Next, the numerators and denominators are just written because the powers go for each of them. I can see that 3 cube and 3 cube will get cancelled, and 7 raised to 3 divided by 7 raised to 2 is nothing but 7 raised to 3 minus 2. Division means subtraction of the powers. Or you can simply say 7 squared cancelled and square cancelled, so 1 is left. So what is left is 7 into 6 squared, which is 36, and 2 cube is 8. This can be cut further and then solve, and final answer is 31.5. 2.2 is simplify. So we have this expression. This dot means multiplication. In chemistry it means a chemical bond, a weak one. Well, no matter how complicated a sum looks in indices, you just have to follow the laws and you will get the answer. So just follow the basics. When the power is minus 1, just take the reciprocal of the whole thing together into. Here the negative 1 is for a, so 1 upon a. -1 for b, so 1 upon b. Take the LCM out here. So it's into b and into a. So that becomes b plus a upon ab. So a plus b and a plus b gets cancelled. So what is left is 1 upon ab. That's the answer. We could have written this as a minus 1 b minus 1 also, but that's not required. We can leave it as 1 upon ab. Next, simplify this. Now in such sums, I see that 5 raised to n can be taken common, and perhaps it will be cut up and down and it will disappear. So what we'll do is 5 raised to n plus 3 can be written as 5 raised to n into 5 raised to 3. If you were given 5 raised to n into 5 raised to 3, then you could have combined these two since they have the same base, and you would have written n plus 3 as the power, because multiplication means addition of the powers. We have just done the reverse of that. If there is addition of powers, you multiply the two numbers. Similarly, separate this into 5 raised to n into 5 raised to 1, which is not to be written. Now in denominator already there is 5 raised to n, so take it out common. So what is left in the bracket is 9 minus, and 2 squared is 4. Now again in numerator, 5 raised to n can be taken out common. By the way, there is 5 cube and 5, so we could have removed 1 5 also common, but I choose not to do it. So I get 5 raised to n out. What is left inside the brackets in numerator? 5 cube is 125 and 6 into 5 is 30. Now 5 raised to n is cancelled. So what is left is 95 upon 5, and the answer is 19. Next, 3.1 is evaluate, which means just solve it and get the final answer. Square root of 1 upon 4 is simply 1 upon 2. Now here I see a power of minus half. So first let's get rid of the minus power. That is, let's do the reciprocal of this. Now remember, 1 with any power is the same number 1. Now 27 is 3 cubed, so here the 3 and 3 gets cancelled. That leaves with 3 squared. And also when you see a power of half, it simply means square root of that number. How to find the square root? Now I know that the square root of 0.01 is 0.1, so you can directly substitute that number. But if you don't remember these values, then you can convert the decimal into a fraction first of all, like this, and then find the square root. Square root of 1 upon 100 will be 1 upon 10, and 1 upon 10 is 0.1, and 0.1. Get rid of the decimal into 10, so that becomes 10. Now how to solve this further? Either you can do LCM method and then solve it, but I'll do it directly. 10 minus 9 is 1, and 1 plus half is 1.5. Now you may wonder which rules have I applied. Let me assure you, I have followed BODMAS and this is the answer, but you can do whatever method you are comfortable with. Now simplify each of the following and express with the positive index. So here they don't want us to solve till the end and get the answer. Just we have to get rid of the negative indices and the number should be as small as possible. So let's start. 32 is 2 raised to 5 and 125 is 5 cube. So now 5 and 5 get cancelled and 3 and 3 get cancelled. So what you're left with is 2 raised to minus 2 divided by 5 raised to minus 2. Get rid of the negative powers by doing reciprocals. But there is a division out here, so again do reciprocal of this. So you get the final answer as 5 square upon 2 square with positive indices. That's it. That's the final answer. If they would have asked us to evaluate, that is find the final answer, then we could have solved further. 25 upon 4, which would be 6 1 upon 4. Yes, we should always leave an answer in mixed fraction, but no need to do this for this sum. Now the fourth sum, mark it as Iymp. We see some nested expressions here. So we should start with the innermost bracket and then work our way outwards. I see 3 negative powers of 1 here. And negative 1 means reciprocals. So let's start with the innermost bracket. It is raised to minus 1 means we'll take the fraction that is reciprocal of this. So that minus 1 disappears. The rest of the powers copy as it is. Next, let's solve the curly brackets first, the innermost bracket. LCM. So if there is 1 minus n here, so I want the denominators to be same. That means even here I'll have to do into 1 minus n into 1 minus n. So it becomes 1 minus n minus 1, numerators together, and denominator is common. Copy the rest thing. 1 and minus 1 gets cancelled. So what is left is minus n upon 1 minus n. But there is a minus 1 out here. That means we should do the reciprocal of this to get rid of this negative power. Now let's open the brackets. There is a minus sign here. The denominator's minus sign becomes the minus sign of the whole fraction, and minus into minus becomes plus. So this is what we get. So now only one bracket is left. Let's solve the bracket in the inner part of the brackets first. Again, the LCM is n, so into n into n. So that becomes n plus 1 minus n, then the common denominator is n. The power is minus 1. Here again n and minus n get cancelled, so it's 1 upon n raised to minus 1. And now we'll have to do reciprocal again. And the final answer is n. Often in life, what seems to be too complicated turn out to be something very simple. Now mark the sixth sum as Iymp, although it's pretty simple. What is given is 1960 is equal to 2 raised to a, 5 raised to b, and 7 raised to c. So let's do prime factorization of 1960. After doing that, I'm able to write 1960 as 2 cube into 5 raised to 1 into 7 squared. Now on comparing, I see that a is equal to 3, b is equal to 1, and c is equal to 2. So we'll use these values in the given expression, and on substitution and further solving, we get the answer as 7 upon 200. Next, 7.2 is Iymp. So was the sixth sum. Now here you can guess that this 3 raised to 3n should be taken out common and should be cut, just like in 2.3 sum. It's not clearly obvious, but on solving further you will agree with this. So first things first, let's convert big numbers into smaller numbers. 27 will become 3 cube. So this cube, this power is being multiplied by the n plus 1. 9 is also 3 squared. Now open the brackets. Here it becomes 3 raised to 3n plus 3. Distributive multiplication, which becomes 3 raised to 3n into 3 raised to 3. So here, instead of having 3n plus 3, I split the powers. So I did multiplication. You know, multiplication means addition of powers. So addition of powers means multiplication of the bases. Even here, I split the powers. So it became 3 raised to 3n and 3 raised to minus 1. In the denominator, on the other hand, the 27 became 3 raised to 3. So that is multiplied by n. And 3 raised to 3n is common. So take it out common. So what is left inside the bracket is 8 minus 5. Now in the next step, again, this 3 raised to 3n and 3 raised to 3n is common. So take it out common. Of course, I see some 3 squares also can be taken out, but I'm not going to do that. My focus is on 3 raised to 3n to be taken out common and the rest in brackets, because then 3 raised to 3n can be cancelled. On the other hand, let's see what is left in the brackets. Here we have 3 into 3 raised to 3. That will become 3 raised to 4. And 3 raised to 4 is nothing but 81. And here what is left? 3 squared into 3 raised to minus 1 is, this is nothing but 3 raised to 2 minus 1. You know, when you multiply, you have to add the power. So that's 3 raised to 1, so which I wrote here. So this is totally 84 upon 3. So the final answer is 28. Now mark the ninth sum as Iymp. It's a proving sum. The LHS is given and we have to prove it to be 1, the RHS. Now that is the biggest hint. I think it will be something raised to 0, because anything raised to 0 is 1. That means all the powers are going to get cancelled. So we simply have to substitute the values of A, B and C. The values of A, B and C are given. So substitute it out here. So what I'm going to do is, these 3 expressions, these 3 terms, I'm going to multiply them. I'm going to find the value of them separately, first of all, by substitution. So these are the 3 terms: the first term, second term and third term. Now A's value is given, which I've written in brackets, and the power I've written outside the bracket. Similarly, I did it for B and C. So you can see that the expressions become quite big. So it's better to solve them separately, and then we can start with the LHS and directly substitute the final values. Otherwise, it won't even fit in a line. So let me solve them separately first. So when I substitute the value of A with the given expression, this power, which is outside the bracket, will obviously go for X as well as for Y. When it goes for X, it becomes a formula: M plus N, M minus N is M squared minus N squared. And when this power goes for Y, the power becomes L into M minus N, and you can open the brackets, a distributive multiplication, which is ML minus NL. We can't solve this any further, so this is what we will substitute for this term in the LHS. Similarly, substitute the value of B with this bracket. The power goes for X as well as Y. Simplify further and get the final answer for this term, and do the same for C. Now we are ready to start with the LHS. So in the LHS, as I said, there are 3, let's call them terms, and for each term I have substituted the values. This is the value of the first term, which I got here. This is the value of the second term, which I got, and this is the value of the third term, which I got. Now there are 2 types of bases, as I see, X and Y. You should be able to clearly see the difference between the bases and the powers. The bases are XY, 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 and the powers are in M, N and L. Get the like terms together, the same bases together, X, X and X get together. It's multiplication, entirely multiplication. Even the dot is a multiplication. So with the x's together, I can simply add the powers. So when I add the powers, as predicted, things get cancelled, and I get x raised to 0. And when I get the powers of y together, addition of all the y powers, because the base is same, again they get cancelled. So I'm left with y raised to 0. So 1 into 1, answer is 1 RHS. Now don't do any manipulation and blindly cut everything. Make sure you check that the step is correct in exam. Now mark 10.2 as Iymp. We have to simplify this. So there's no LHS, RHS here. We just have to solve and get the answer. Now the first thing I will do here is, when I see a negative sign in the denominator, I'll shift it up. So it will become A plus B, because the base is same. Get them together, get the powers together. So the power is A plus B. And the power outside the bracket will be multiplied with this power. So it will become two brackets multiplication in the power, and the same thing will happen with this term as well as this term. Now, not surprisingly, this is a formula. This is a cube plus b cube. This is b cube plus c cube, and this is c cube plus a cube. Again, the bases are same, x, 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 so get all the powers together. There is addition, so no cancellation here. It's simply 2a cube, 2b cube, and 2c cube. Get 2 common in the power, and that's your final answer. Now, you can guess that in 10.1, it will be similar, but this time the powers will become, in the end, a cube minus b cube minus c cube, and c cube minus a cube. So now you can guess what the final answer will be in 10.1.